All right, so what we're going to do today is we're just going to take a quick look at how we can get ourselves a visualization that looks like this on the right. It's not the most complex thing, nor is it the best looking thing, but it's just what I came up with today. I kind of like the thing. It looks kind of neat, and we're just going to go over how we get to something like this. So I'll just remove it so we don't have to cheat, and we'll just walk through it to see kind of what we're dealing with. So the first thing we'll talk about are the packages that we're using. We're using tidyverse. Tidyverse contains things like dplyr, tidy text, and ggplot. I also have a kind of redundant ggplot call in here, but that's just there in case, I don't know, something fails. I use stringr. I use stringr particularly if I'm looking at regular expressions and trying to kind of get things out of text. Forcats is here for changing or dealing with categories and reordering things reverse in the order that they're in. And then patchwork. Patchwork is something I've only actually used today and is used to combine multiple plots within one plot image. Then I'll be using these Marvel CSVs and the DC CSVs. These are all taken from Kaggle. I'll put the source in the video so that so we give them credit definitely where credit is due. And then I'll just kind of break it up where I'll just start with Marvel first. And what you'll see is that the actual basis for the creation of the plot is essentially identical from Marvel to DC. The only thing that we're really going to be changing are some of the text options and also just the colors to try and kind of match the color scheme for it. The first thing we do is we just start off with kind of just looking at our data. We can do that pretty easily with Marvel, and then we'll just kind of pipe that into a view command. And when we pop up, we'll see we have all these different things. So we have things like the page IDs. I'm assuming that's just kind of a reference as to when this database was created, the name of the character, the ID, the alignment, the eye color, and hair color, sex, alive, status, their appearances, first appearance, and the year of that first appearance. Now, all we're going to use in this data set, or at least in this visualization, is going to be their first appearance, or actually the year, and actually that's kind of it. So just the year. What we're doing is we're just going to be assuming that the way this is going to work is that we're going to be using this page ID almost as just a numerical basis for the name. So even though we're not looking at specific characters, we're looking really as just, okay, so we have, let's say, 16,000 some odd characters here. How many of them were in this year, so on and so forth. So really just using the year column here, and we're kind of in the background using the other columns to serve as a basis for, they represent each character that's there. And now the first thing I was interested in is when I was looking at this is, okay, how do we actually get the dates? And I wanted to look at this as kind of characters created over time, less as a time series plot and more as a, let's group it together. So I don't really care about, who was in 43 or 45 or 56 or 78 or 95. None of that. I really care about the decades. And there are definitely, I'll put a disclaimer here. There are definitely better ways to do this. There are definitely better ways to play around with the dates and time and all that stuff. I just chose to do it this way. Why? I don't know. It's just kind of how I was able to wrangle it. So if we look at this and we just say we're going to have Marvel, we'll pipe Marvel into something to just look at the years, right? So we'll say select year. What we'll get over here is we'll just get what looks like this on the right-hand side. These are all the years over here. Now we do have some NAs, and I'll just be omitting those because there's no reason to put that in the data, and it just kind of muddies it up a little bit. So we'll just say select year, and this is what year looks like. Now, what we don't have is we don't have anything that seems to tell us how can we actually make this into, let's say, a decade. So what you'll see in the bottom is the walkthrough of that. So the first thing we'll do is we'll just do exactly what I said down over here. And we'll mutate this, and again, mutate is just making a new column. We'll just say year S. And the reason I call it year S is I believe I meant to say year S as in year short, or short version of the year. Now I believe I could use a package like lubridate to change the years. Not going to do it just because the way I'm doing it is not looking at the years as in 40, 50, 60, 70, 80, but more as a kind of text 40s, 50s, 60s, 70s, so on and so forth. We'll say year S. And then what we'll do is we're going to have a string extract all. And what this will do, this will take the text out of the data that matches this particular regular expression. And we're going to be using the year column, as you said before. And then we're going to have this regular expression. And it's going to be a look behind regular expression. And I'll tell you that, as much as I'd like to think I understand regular expressions, there's still a lot that I don't understand. There's still a lot that just it works through trial and error, or me just staring at my screen for the 30 minutes trying to figure something out. What we'll do is we'll start off by saying we're going to create a look behind that essentially says I don't want you to pay attention to everything that starts with these first two characters, right? Because all the years are going to be 1991, 19 something. So that 19 we don't care about. We don't care if it's 20 either. We don't really want that to be there. So this essentially tells it to, if we have a number like, let's say, 1992, it's going to say, just give me, or really, we're looking at this, and we don't want that. So we're going to say, just go in front of that. So the caret means at the start of, the dot is just a placeholder for a character, and then we'll follow this by another parentheses and a dot, which will just be get me the last two characters. So if I just do this, and if I just, let's say, we'll just call this samp date, right? And then we'll actually have to make sure that it's quotation marks so we can do regular expressions on it. The samp date will be 1992. And then I could just say string extract all, or since there's just one of them, there's no reason to do all, so I'll just do string extract. And then I'll say, okay, so get whatever is in samp date, and then we'll just do our same expression. So question mark, less than, equals, caret, dot, parentheses again, dot, and then we'll see what we get. We get 92 from there. And if I leave that out and I just do, let's say, the first part, I'll be getting nothing, because it's saying, again, it's asserting this so that it only exists to say, look at everything after this. Don't look at what's in the parentheses, in this look behind, look afterwards. So this is actually called a positive look behind. I'll have to check, because again, I use regex101.com like for everything. So I go there and I kind of check against it and see what it works. And it's a very cool interface because it kind of dynamically tells you what are you actually capturing, what are you actually doing there. So that gives us the idea that, okay, we can get the numbers from there. So I do this, and then I just say to make this year S, I get this. And what I'll do is just to kind of filter it out so we can see, I'll just then say select year S. And then I'll get just this over here. So I have things like 63, 07, whatever, so on and so forth. And I have my decades now. What I want to do is I want to essentially just say, only look for what does it start with. Because what I want to do is I want to take the values that are 92, 92, 94, 95, and I want to compress that. I want to take everything that starts with a 9, make it say 90s. Everything that starts with a 0, make it say 2000s or 2010s. If it starts with anything, let's say, less than 1, because there were no superheroes created, at least according to this database, from a year, I believe, before 1940 something. So what we'll do for that is we're going to end up using case when. Now what we could do is we could use something like if else. And I could say, let's say if I had a couple of years, so we'll kind of recreate samp date, or at least we'll just make it so that it's something else entirely. So I'll just say round, and then I'll just say run if. And we'll just say 1940 to 2000, right? And then we'll just say, give me 10 of these. And then just to finish the round over here, we'll just say to 0 places. Okay, we'll look at what the samp date is, and then we get these as our dates, or as our years rather. So I could just say if else samp date. No, sorry. It's going to be if else string extract all samp date. So what we'll do is we'll just say if it starts with anything between 4 and 4 and 6. We'll go from the 40s to the 60s. So we'll say if it starts between 4 and 6, to make that say 40s to 60s. Else, now we'll say string extract all No. Okay. So what you're going to see there is that what's happening is I think the syntax just kind of escaped me entirely. So we're gonna just trash that and just go to something else. And what you'll see is that again, if else is great for a few things. If else is good if you're looking at a dichotomous thing. So if it's equal to this, do this. If it's not, do that. Okay, that's great if you're looking at just a one or two type variable. But with dates, we're not looking at that. So we're looking at a kind of we need something called case when. And case when is essentially just if else, just a bunch of different times. I believe the description calls it a vectorized if else against a vector. So what we'll do is we're looking at case when instead. And what we're going to do is we're just going to say, for this over here. So now we have this year s type thing. Now, we could probably have made this into one mutate, but there's no reason to do that just because I want to demonstrate it that way. So we'll just have another mutate, and we'll have this mutate be a variable that we'll just now call decade, and this will be the one that we're going to be looking at. So decade will just be saying that it'll be equal to case when, and the syntax for case when is essentially to have a formula, and it's denoted by something where, let's say you have a formula here, and then it'll be equal to some value. And that's what you're saying. You're saying if it passes this formula, and what it will tell you is that it needs to have a logical operator there. So you can't do string extract, you can't do string match. You have to do string extract or string detect rather, because string detect will return to you a logical, either a true or false. And then what it will say is if it passes this test, if it is true, make it this. If it's not, then do this. And it kind of runs down this list. So the first thing I'll do is I'll just say string detect year s, and then the regular expression for this will be, let's say, _4. And _4 will be telling it if the year starts with a 4, because again, now we're looking at the shortened year. So now it's no longer 1995, it's just 95, 96, 43, 67, 55, whatever it might be. This will say this is the logical that it has to pass. Is it actually true or false? So if it's true, we're going to have this little tilde that tells it, if it's true, do this. And then we'll say that now this will be equal to 40s. Okay, so we'll go over here. And what we can do is we can essentially just take this, copy this down, and try and keep the formatting somewhat in there. And then I'll just go down here and a little bit, annoyingly, because I didn't do the way I wanted it to, but that's okay. So we'll just do this, and then we'll have probably one more copy in there, and we'll just change this one to 1 because we'll see why in a moment. And then we'll just change the name over here. So 50, 60, 70, 80, 90. This will be 2000s. I haven't really found a better way to phrase that. There might be, but I just don't know what it is. So 2000 and 2010s. So then if we do this, and then we'll also want to make sure that the parentheses, they do match up over here. And we're going to pipe this into a select feature, and then just say, okay, now I want to see what did I actually make? Did it work out? And we do this and we find out, yes, we do have that. Now, just to kind of get rid of those omits, I'm going to just do an NA omit so that we can just get rid of that. And it doesn't really seem like an eyesore anymore. And we go over there, and that's perfect. All right, so we have what we're looking for over here. Great. Then we're going to do a few more things. The first thing we want to do is we want to actually have a count over here to see how many characters existed or were created or introduced in the 40s, the 60s, 70s, so on and so forth, to try and figure out, was there a certain decade that really lent itself quite a bit to character creation. So then we'll do this. We'll say NA omit to that get rid of the NA values, and then we're going to pipe this into a count feature. And the count over here will tell us 15,492. We're going to hold on to that number afterwards. And what we're going to realize now, what I just realized now, is that the way this works is going to be, we're going to omit all the NA values, and instead we're going to group by. We're going to group by the decade. And group by the decade will just tell the data, will tell R, I want the next thing you're going to pipe into to be grouped according to this particular variable. And this will be the group by the decade. So when we do the count over here, then we'll have something that looks like this. We'll have the 2030, 86, 2010s, 1041, 50, 302, so on and so forth. Right? This is what we want to see. This is what we'll be using for our final data visualization. And the last thing we'll do is we're just going to ungroup it. We don't want to have any more grouping there, so we'll just get rid of that. All right, so we ungroup there. We have that. Perfect. All right, and this is exactly what this is over there. So we can kind of just get rid of this. Now what I'll do is we'll talk a little bit about the plotting. So the way that I worked this out the first time was I didn't really factor in fun pun there. I didn't factor in the idea that how the text would factor just by default. So we're just going to build the plot and then just kind of go backwards from there. So the first thing we can do is we'll just make our plot. So we'll just call it. We'll just use Marvel because we didn't. We saved this as Marvel. So I'm sorry, it saved actually as Marvel plot. So we'll do that again. Marvel plot over here at Marvel plot is just the data we had from before. Right, perfect. Now, what you'll notice is that I have already kind of preemptively factored it, but I'll go over that in a moment. And we'll just do it now, actually. So what we did is we just did Marvel plot decade, and then we kind of assigned that to be a factor of Marvel plot decade, giving it the appropriate labels, and then telling it to order it according to those labels. And that'll help us out in the end, where we'll have our data appearing in a time fashion. Usually, if we're talking about something that's not time, kind of not locked in any time variable, we have free reign to be able to arrange it so it looks nice. But in this case, we want to look at it in time order to see, is there actually any seeming relationship or even, seeming thing we can pull out of there, looking at it as a chronological order as opposed to just which of the decades have the most amount of creation of characters. So the Marvel plot we'll start off with over there. And this is going to lead into a ggplot. So we'll have a ggplot over here. And again, we have two variables. We have decade and we have n. So we'll just part this out with the aesthetic. We'll say decade and n. Then we link it together with a plus, and then we'll just say geom bar for a bar plot, and then we'll say stat equals identity, so it knows how it's actually plotting this. So if I leave it just like this over here, we're going to get a bar graph that looks a little bit like this, supposedly, right? Nothing frilly about this, nothing at all. This is not looking good. It's very, very plain, but again, we're missing a lot of aesthetics that we're going to be adding in right now. The first thing that I like to do is whenever I have a bar plot, I like to always flip the coordinates. I think it just looks better to have it on the side as opposed to just sitting like that. So just by doing this by itself, it already kind of makes it look a little bit better. It spaces out a little bit. It just looks neater, right? So we have that. And then what I'll do is I'm going to add in my labels. Now what you'll see is that the way that I do this, the way it's written is not the way that it was before. I went through about 10 different iterations of this to see what looked the best, what I liked, what I didn't like. And then I went from there. So we'll just have actually, we're going to omit the labels because the way it's going to work at the end is we're not going to have labels to begin with. But what I will have is I will have something else where I'll say, actually, we'll put it over here instead where I'll just say, make this fill white. And if I do this without kind of changing things at the end, it's going to make it just look blank, which isn't going to help us at all. But so I'll leave that off for right now because we're going to be changing the background and everything to go from there. So we'll just say chord flip, go from there. And then this will lead into us giving it a label. So we'll say geom label. We'll pass it through to values, and we'll just say that the labels, we'll pass it through the aesthetics, and then say the label equals n. So by doing this, then we'll have labels on our chart. Because what we're going to do is we're going to end up removing all of the axis titles, all the axis text, the axis lines, everything from there, just leaving us with the dates over here, and then just the numbers on the side. So we'll have our label over there. Then we'll go through, and now we'll just start cleaning it up a little bit, right? Because the data we have already, the data is there. It's just a matter of how do we communicate this? How do we actually pass this through? So we'll have the theme classic. I like this one quite a bit. And then this is where things it's just things we take off. So things like we pass everything through the theme function, the theme argument rather, and we'll just say first thing I want to get rid of. I want to get rid of the axis ticks. So axis.ticks, and then we'll just say element blank. This will get rid of all the ticks on the chart. Okay, so it looks a little bit better there, supposedly once it loads. Perfect. All right, then I'll start doing something else where now I'll say I have the axis ticks, and then we'll do these two. We'll say plot background equals element rect with fill equals, and now I'm going to just copy this over, but I had went on Google and typed in Marvel logo. Then I used a color inspector, kind of like a color picker, eyedropper, whatever the little icon for it is. And then I just kind of got the Marvel logo from there. Now, some of them looks very stark red, and I try and shy away from using very, very anchored colors where it's just, stereotypical red. I like to use things that are in between, kind of a more maroonish or a darker thing, but I tried to stay a little bit true to that. And I'm just going to I'm going to go over here, just Command Shift Left, copy this because it's going to be the same exact thing, except we're just going to be changing the word over here instead of being plot background to being panel background. This will change everything accordingly. So once this is there, I will now just add another parentheses over there that kind of locks in the theme. I'll do this, and then we ended up with this. So it looks kind of okay. And now I can go back, and now I can go to the geom bar, and then I can say, all right, you know what? Now give me a white fill over here, because then it makes sense and it kind of works out in our favor, right? So we're looking kind of okay, not too bad. But you notice that the text is still the same color as before, and we don't want that. So we're going to change that right now. So we're going to go over here, and we're going to say, give us all the axis, all the axis text, make that element text, and make that color equals white. So that'll make all the axis over there. Then I want to say, now give me the axis title. Do the same exact thing. It honestly, it looks kind of like Spider-Man, and I wasn't really going for that, but it worked out like that, and I was okay with seeing that because it made me feel like, oh wow, it's actually working. So then we have the axis title, the axis text, and now everything will be from there. Now, if you notice how what it's doing is it's going to by default give us these titles that are linked through the ggplot. So this is why we have to go back and we have to actually make the new labs function to just say I want x to equal nothing and I want y to equal nothing either. And of course, we'll just pass that off with a plus to link everything up. So that's over there, and then we have something that looks like this. So now we're getting kind of close to what we're looking for. I don't want the lines, and I don't want the text over here. So what I'm going to do is now I'm going to say, get rid of the x-axis. Remember, everything is flipped, so I will confuse it probably several times. So now I'll just say axis text on the x, axis text on the x, sorry, element blank. I go over here, and now that axis will disappear. Cool. And then I'll also do the same exact thing for the line. And I'll just say axis line, just in general, element blank, because I don't need it there anymore, because I'm trying to make this visualization as apparent as possible without having the axis lines, ticks, or the titles to really, tell you what it is. All right, so now we're looking much like what I'm trying to get this image to paint. So then what I'll do is then the next thing, once we have all of our lines there, you'll see there's no legend over here, and there's no legend actually because of the way that I formatted it that I can kind of use going forward. So then what I wanted to do is I wanted to add something there to basically try and illustrate, okay, so from over here, what is the actual total number of characters created from here? So I'll use the geom h line for that. I'm gonna get out of the theme over here, and then just again do geom h line. And this is a bit of playing around, but essentially we have the y-intercept being 5,000. The line type is 2, so it'll be a little bit dashed. And the color is white, just to keep in with what we've been using before. So over there, and then what I'll do is then I'm going to actually have another thing where I have an annotation. I'll make sure that it's on the other line, so annotate. And then this is going to be the geom that we're going to use as text. X is 5, Y equals 4,700. Now, a lot of this is really just playing around with things to see how does it look, what looks best. And I didn't give it a label because I just forgot. So I will go back and then there we go. That's why. You see on the bottom. So it's going to be, I told it I'm going to use text, but I didn't tell it what the text is supposed to be. So label is going to be, it's going to be paste 0, and this just lets us use a variable that we had before, which again, remember, we named that Marvel total, or we got the total from this. We'll say that equals total, and then we have this other thing where now we're going to say, so we'll say total equals, and I'll just give it a space for just formatting. And we're going to make this just so it looks nicer. So remember, the value that we have saved over here, I'll just kind of go on the side so you can see. If I go to Marvel total, the value that we have is 15,492. Now, again, what you're going to see is a lot of things that I do, there are definitely better ways to do this. This is just the way that I'm doing it right now. So Marvel total does exist as 15,492. However, it's actually, if I did an up on this, right, and I did a class of what this is, it's going to tell me it's a data frame. I don't want that. I want an integer value. So I have to actually go over here, go back in, $, see what's stored there, total. Now I have integer, I can use that. So I'll go back over here, and I'll say Marvel total. Then once I do this, then I get the value I'm looking for. supposedly. We'll see. Who knows? Maybe. Stay tuned. All right, so we didn't get that, and I don't know why. So I'll do it again to see what's going on there. Annotate this. There we go. So we have this over there. Total V for some reason because I just messed up. And okay, a couple things we want to change. So the one thing we want to change for sure is going to be I want the color to be white, and I want the angle to be 270. And then I'll just flip it around. I think it just looks nicer when it's like that. Okay, so it looks kind of cool. What I wanted to do originally is I wanted to actually see if I could find a way to have a little curly brace over here to illustrate the idea this is a total of all these numbers. Didn't really do that just because there was a few different packages. I wasn't really too sure about their usage and didn't want to really go too in depth just for this first thing. And then this is essentially copied verbatim to the below graph. So I'm going to delete all of this. And then we go to DC and the same exact thing. The only main difference really is that DC plot, the DC CSV, it uses year, but in all capitals, so that the text is a little bit different, but everything else stays the same. So the same case when argument, the same total argument, the same factoring, and then the plot is the same. The only thing that's changed over here is just the values for the background colors. Then I use patchwork. Patchwork is something I've never used before, and I really do like it actually, where you can combine two plots together. So very, very, very easily. And well, we'll just, yeah. So if you look at it this way, if I do patch 1 and 2, if I just run this over here, knowing what it's supposed to be, I get P1 and P2 side by side, right? And by itself, that looks fine. But I wanted to just change a few more things around. So and I'm not gonna type it again just because the way that you'll see it's spaced, it's kind of shoddy, but it still works, and I do like that. So we have over here, we have the patch. There's a separate function of plot annotation. We go to title. The \n is called an escape character, so it makes a line return, and it just tells it to essentially. And I'll just do this. You can see again what patch W looks like. But the \n gives us the line break originally, just to kind of push it down from the screen. And then I'll have a subtitle over here for character appearance by decade, and then 2 more line breaks, and then in honestly the best way possible to make the spacing like this without any command or anything like that, just hitting space and going for a trial by error thing to get the spacing the correct way. We give it a caption over here, so it's from Kaggle, my Twitter handle over there. Then you can just pass the theme function inside of Patchwork, give it the different background, change the text, and then export it. So this is what we're left with. And I think it's a nice graph. I like it. Now it doesn't tell us some things. So what it doesn't tell us is of the characters that are created over here, how many of them are actually superhero or villain characters, and how many of them are just neutral characters, right? And then should those still be there? Because if we're talking about character creation, having a character that's just a person who's in a panel, who's introduced as a friend or something like that, are they really a character if they have no real role in the universe over here? It sounds kind of philosophical, but it's not meant to. And if we just look at this very, very simple Marvel alignment thing over here, we see that we have about 2,200 characters that are neutral, over 2,800 characters that have no alignment at all. So it's kind of weird to think about, okay, neutral characters and then no alignment. What does that mean? And honestly, just for anyone who watched the video, maybe if you stuck through this whole entire thing, if we actually look at this and we say, let's look at the alignment, and let's just view this, right? Let's just view this data and then look at it together and see what's going on here. So I look at the alignment. I'll have to scroll to the left a little bit or the right a little bit. And if I just go to the correct thing, I'll go to alignment, and then I'll just say to sort it, we have people who have things like, align, sort that. So all these people, Red Wing, Microtron, Ego, they definitely sound like characters. They sound like characters that have some basis of importance, right? But it doesn't give us that data, and sometimes we don't get the data we're looking for. So I'm just trying to kind of think about what visualizations might be interesting here. One thing I was trying to look at was to look at the names of them to see how many superheroes have just one name, right? Just have one one name, one moniker they go by, and not some long name or something like that. And that'll be kind of something I might look at next time. But this is what we end up with. So I hope you found this helpful in some extent, and I plan to do more on things like this, just because I think that data visualization is such an interesting thing, and especially when you can kind of marry it to something like this, where you're not just looking at your data, you're looking at data that could be interesting, and this might either spawn a brawl in the comments, or it might spawn a discussion about the nuances of character creation. But if we look at this, just looking at 15, almost they almost duplicate, almost kind of more than 100% of the total DC characters. And again, I haven't looked at the DC alignment, but I don't know what the proportion would be of neutral, good, bad characters in the Marvel versus DC, which might be interesting as well. But I hope you liked this video. I hope you found it helpful in some capacity. And if you do, leave a comment or something like that, and then I'll just know that I can make more, or I'll probably just do it anyways, because I think it's good to have a little bit of a back source of things that I can use to show everyone what R can do and how fun R is to use. So I thank you for watching, and I'll see you next time.